Hello everyone, this is Liang Junwu, and today I will talk about homework 10, the first and second question. The first question is ask us to collect the definition and simple properties of the examples of stochastic processes. There are 7 examples, and the first one is Poisson process. The definition of Poisson process is when x0 is equal to 0 and xt1 minus xt2 is equal to the number of calls received in T1 and T2, the interview, and the probability is this equation, and the properties is the points in non-overlapping interviews are independent. That means if the t equal this equation, and the probability this two thing is can multiply independent, and the mean of Poisson process is limiter t, and the autocorrelation is equal to this thing. The second example is Poisson increments, and the definition is with xt is a Poisson process like before, and epsilon is larger than 0, then yt is this equation, and the mass function is probability yt equal to n over epsilon is equal to this equation. Just rewrite this thing, and the mean of Poisson increments is the limiter, and the autocorrelation is equal to this two things when T1 minus T2's absolution is different. And the second example is Poisson impulses, and the definition is Ct is equal to limit epsilon is going to 0 and yt, and the mean of the Poisson impulses is equal to limiter, and the autocorrelation is equal to limiter square add this thing. And the fourth example is semi-random telegraph signal. The definition is xt is equal to 1 or minus 1 when k is even or odd, and the mass function is probability xt is equal to 1 is equal to e minus limiter t minus Cauchy limiter t. Cauchy limiter t can write this thing. And the probability xt is equal to minus 1 is equal to this thing. Sinch limiter t is equal to this thing, just write plus to minus. And the mean of this example is equal to limiter minus 2 limiter t, and the autocorrelation is this absolute. And the fifth example is random telegraph signal. The definition is let A be a random variable independent of xt, And probability A equal to 1 and the probability A equal to minus 1 is both is equal to 1 over 2, and yt is equal to a minus xt. So the probability yt is equal to 1 is equal to probability yt is equal to minus 1. This is both equal to 1 minus 2, 1 over 2. Sorry. And the mean of random telegraph signal is equal to 0, and the autocorrelation is equal to this thing, because the mean of a square is equal to 1. And the next example is random walk. The definition is xnt is equal to ks minus n minus k multiply s. The k is equal to number of head, and n minus k is equal to number of tail, and xt is equal to xnt. So we can get probability xnt is equal to this equation, and the mean of random walk is equal to 0, and the autocorrelation is minimum n and m minus s square. And the next process is Wiener process. The definition of Wiener process is limit s is like this, and we can get the CDF of Wiener process is equal to this thing, and the PDF of Wiener process is like this. The mean of Wiener process is equal to 0, and the autocorrelation is equal to this. Alpha is a constant. Then we look at the second question. The second question is asked us to collect the definitions of properties of stochastic processes. This 7 process is general process. So the first process is wider sense stationary process. The definition is mean of this process is a constant, and the autocorrelation is no related to the T1 and the T2, just related to the minus T1 minus T2. And the second process is independent increasement process. Increase process. The definition is the probability xta minus xtb less than x1 and xtc minus xtd less than x2 is equal to this separate multiply this two probability. And the next process is Markov process. Markov process, the definition is the past has no influence on the statistic of the future under the condition that the present is null. That means this equation. The probability xt1 less than x1 given xt1, xt3 and xtn is equal this thing, and this probability is equal to just given xt2 is equal to x2. So this is no influence on the future statistic. The next process is normal process. The normal process, the definition is random variables xt1, xt2, xtn are joint normal, and the PDF of this n random variables are equal to this, and the statistic of a normal process is completely determined in terms of its mean and autocorrelation. So this process can be called the normal process. And the next process is strict sense stationary process, SSS. And the definition is its statistic is not affected by a shift on the time axis. That means two process xt and xt minus epsilon has the same statistic for any epsilon. This sentence can be rewritten this equation, and there are many properties of SSS process. We can see fxxt is equal to fxx, and the mean of xt is a constant if the mean is exists, and the PDF of SSS process is related to T1 minus T2, not T1 and T2. And the last properties is autocorrelation is equal to is not related to T1 and T2, just related to T1 minus T2 if correlation exists. And the next process is white noise. White noise can be written VT. VT is if the correlation T1 T2 is equal to Q T1 delta T1 minus T2. This can be white noise. And the last process is mean ergodic process. This means it is equal to this equation, and in mean square sense, then it can be called the mean ergodic process. That's all. Thank you.